Now see this video. What do all acid and all bases have in common? See, we'll going to discuss this. Already we seen the previous lesson, that is previous topic. The acid have similar chemical properties. That what leads to the similar in properties? We saw in already seen that some reaction like acid generates hydrogen gas on reacting with metals. So hydrogen seems to be common to all acid. So now we can do one activity like this. That's mean we can do in our laboratory. Just I will tell you that when take glucose, alcohol and hydrochloric acid, sulfuric acid. Take glucose, alcohol, hydrochloric acid and sulfuric acid. See here, I'll take all this substance and fix 2 nails on a cock, that is placed in the 100 ml beaker. Then the connecting the nails to the 2 terminals of 6 volt batteries through a bulb and switch. So when now pour some dilute hydrochloric acid, so what happens mean now the switch is on. So repeat with sulfuric acid also. What happens? See, repeat with glucose and alcohol also. What happens mean that bulbs will glow. Why the bulbs will start glowing on the case of acids mean? See, you will observe that glucose and alcohol solution do not conduct electricity, but that hydrochloric acid and the sulfuric acid contains, when you pour in the solution, what happens? They glow the bulb. Why? See, they are the hydrochloric acid and the sulfuric acid contains the H plus and the OH minus ion. So they produce current, that is the electric current is carried out through the solutions by ion. So since the cation present in the acid is H plus, this suggests that the acid produce hydrogen ions in the solution, so which are responsible for the acidic properties. So, okay. See, what happens to an acid or base in a water? Usually, the acid or base in water means, see, the hydrogen ions in HCl, that is, the hydrogen ions in HCl are produced in the presence of water. See, the separation of the H plus ion. The separation of the H plus ion from HCl molecules cannot occur in the absence of water. So, HCl gas dissolved in water to produce the hydronium ion and the chloride ion. Only the hydronium ions is called acid, or we can tell it that is H plus. See, the hydrogen ion cannot exist alone. So, but they exist after combining with water molecule. The hydrogen gas always shown in the hydrogen ion or in the hydronium ion. For example, we can write it like this: H plus in the presence of water, that is H plus indicates what? Acid, the presence of water to form hydronium ion, H3O plus. Similarly, we can see that the acids gives hydronium ion or H plus. Either H plus or that hydronium ion we can write in that water. See, now we see that base. See, when you react with base, that's sodium hydroxide pellets. The sodium hydroxide pellets, that is solid form, and react with water, what happens? It converts to sodium hydroxide, that is Na plus aqueous and OH minus aqueous. Okay. See, here also the sodium hydroxide is react with water to produce, sodium hydroxide in water, the solid form of sodium hydroxide react with water, they produce aqueous form of sodium and the hydroxide ion. Similar way in potassium and magnesium ion also, magnesium hydroxide also. See, usually the potassium hydroxide KOH solid, this is also pellet forms when react with water. So what happens? K plus aqueous and OH minus aqueous. Similarly in magnesium hydroxide also, magnesium hydroxide solid form react with water to produce Mg 2 plus and that is aqueous and 2 OH minus aqueous. So simply they are called alkalis. The metal hydroxide simply when react with water they are simply called alkalis. Okay. So acid or base they produce, that is when contact only in the presence of water, then only they are called acid. Suppose for example HCl. HCl gas does not, suppose if the HCl gas only alone means it cannot occur acid, because the a gaseous molecule cannot dissociate into ions. Only the gaseous molecules dissolving the water or contact the water, they produce the ionization, that is in H3O plus or H plus, whatever it is. That is acid or in the base case. Okay. Now we can identify, that is the all acid generates the H plus ions and all bases generate the hydroxide ion. See, this is called a neutralization reaction. Already we seen that acid react with base to produce salt and water. When react with, that is suppose if you use the HCl and sodium hydroxide, it converts to sodium chloride like this. See, the Mx, the excess X will be sodium chlorine, any halogens, metal will be sodium, any alkali metals. So what happens? Mx indicates here any alkali chloride, any alkali metal chlorides. So here Mx means if you using the chlorine and Na means it converts to NaCl and water. Similar in the case of H plus and the OH minus ion. See, H plus is the acid, contains the acid solution, the OH minus ions in the basic solution. Okay. So all bases do not, usually all bases do not dissolve in water, and alkali is base that dissolves in water. Okay. Usually they are soapy in touch, bitter and corrosive also. Okay. See here, before that, the process of the dissolving an acid or base in water is highly exothermic. That is the highly exothermic reaction. So you must add, that is mixing of the concentrated acid, any acid, nitric acid, sulfuric acid or HCl, whatever it is in the water, you must always be added slowly water with the constant stream. Okay. If water is added to a concentrated acid, the heat generated may cause the mixer to splash out and cause burn. Okay. So the glass container may also break due to the excessive local heating. So this is highly exothermic reaction. Now next is the how strong or acid or base solution. See here we know how acid base indicator can be used to distinguish between acid and the base. Already seen, that is the dilution and decrease of the concentration of H plus ion and the OH minus ions in the solution. See, we can quantitatively find the amount of this ions present in the solution. See, we can do this by making of the universal indicator. So which is mixture of several indicators. So the universal indicator shows different colors in a different concentration of the hydrogen ion in the solution. So here a scale measuring the hydrogen ion concentration in solution is called pH scale. See, the pH scale, that is power of the hydrogen. See, generally the pH scales are from 0 to 14. The 0 indicates they are very acidic. 14 indicates very alkaline. Okay, that means they are acid and they are base. See, depends that pH value, we can tell it, that is higher the concentration, that is called strong acid, higher the concentration of this called, that means number 14 means that is strong base. Similarly, lower the concentration, weak acid, and lower the concentration in base solution means that is weak base. In between, we can separate by 7, that is in 7 is neutral. 0 to 14, that is pH scales are available from 0 to 14. 0 to 7, up to 7 is acid, then after that 7 to 14 is called base. Okay. Here we will see that pH of a neutral solution is 7, that is the value less than 7 on the pH scale represent an acidic solution. The pH values increases from 7 to 14, it represent the increase the hydroxide ion concentration in the solution. Okay, so that is increase the strength of the alkali. Next, see the different pH values of the some substances like gastric juices. So the gastric juice, they are acidic in nature because they have values, the pH value is what? 1.2, approximately about 1.2. Then lemon juice having 2.2. Then pure water and blood, they have 7.4, and milk of magnesia, the pH value is 10, and the sodium hydroxide solution is 14. The pH value is 14. Here, the strength of the acid and base depends the number of H plus ion and the hydroxide ion producer. So, if we take the hydrochloric acid and the acetic acid, some same concentration, say 1 molar, that is, then these produce the different amounts of the hydrogen ion. Okay, acid that gives rise to more number of H plus ion are said to strong acid, and more number of hydroxide ions are present in the solution means they are called basic. Okay, now next we will see the importance of pH in everyday life. See, what is the importance of pH in everyday life? Here, are plants and animals pH sensitive? What is the pH of the soil in our backyard? pH in our digestive system? pH change as the cause of tooth decay? Then self-defense by animals and plants through chemical welfare. First we will see, are plants and animals pH sensitive? Yes. See, our body works within the pH range is 7 to 7.8, that is 7.0 to 7.8. The living organisms can survive only in a narrow range of the pH change. So, when pH of rainwater is less than 5.6, it is called acid rain. Already you heard that word, acid rain. When acid rain flows into the river, it lowers the pH of the river water. So, the survival of the aquatic life is such, rivers become very difficult. Then, what is the pH of the soil in your backyard? See, the plants require specific pH range. So, specific pH range for the healthy growth. So, to find the pH required for the healthy growth, the plant, you can collect the soil from various places and check the pH manner, pH manner, and you can note what is the plant growing in the region from you have collected the soil. That means in our country, one areas that is more growing in rubber trees, more growings in that is in rice, like this. So many sites in Tamil Nadu side, it's many districts having the different field works are there. That is that the plants like any vegetables or in that any seeds, whatever it is. So they suppose they depends only the soil. Okay, then the pH in our digestive system. See, it is very interesting to note that our stomach produces the hydrochloric acid, so it helps the digestion of food without harming to the stomach. So during indigestion, the stomach produces too much of acid, and this causes pain and irritation. So to get rid of this pain, people use base called antacid. That is called simply whatever it is. They contains magnesium hydroxide, or simply we can use it, that is sodium bicarbonate, that is baking soda. See, and such remedy must have been suggested, but beginning of the chapter already seen that these antacids are neutralizes the excess of acid. So the magnesium hydroxide, that is called milk of magnesia, a mild base. So it's often used for this purpose. Then the pH change as cause of tooth decay. So the tooth decay starts when the pH of mouth is lower than the 5.5. That is the pH value. So the tooth enamel made up of the calcium phosphate is the hardest substance in the body. So it does not dissolve in water, but it's corroded when the pH is mouth is below 5.5. So the bacteria present in the mouth produce acid by degradation of sugar and food particles remaining in the mouth after eating. So the best way to prevent this clean of mouth after eating food. So using toothpaste, which are generally basic for cleaning the teeth, can neutralize the excess of acid and prevent tooth decay. Then last one is self-defense by animals and the plants through chemical welfare. See, already that is, have you ever been honeybee, that is stung by the honeybee? Bee sitting leaves and acid which cause pain and irritation. See, use of the mild base like baking soda on stung area gives relief. So sting hair of nettle leaves inject methanoic acid causing burning pain. So these are the things are the importance of pH in everyday life. Next we will see the more about the salt, that is the family of salt, common salt, pH of salt we will discuss.